When I go through this here, it says if A, B, C, D are collinear, I drew the diagram for you, and AB equals BC equals CD. My diagram is not yet finished. What's the last thing I can put for my diagram here? The last thing. Okay? Good. Okay, because it shows some sort of equivalent, they all have to have the same distance all the way across. Okay, so it says OC is equal to 1/3 OA plus 2/3 OD. Can somebody give me a suggestion for how to start this one, please? Oh, nobody has a suggestion. Oh, this is awful. Yeah, go ahead. Okay. Okay, good. So we're going to say then, sounds good to me. So we're going to say that OC equals OA plus OC. Wonderful. Okay, now I'm going to tell you the reason that that's excellent for me. Okay? If I take a look, I already have an OA, so it's lovely. So I'm not going to touch that OA. If you did the other way, don't erase, it still could have worked out. Okay, right? But that doesn't work. Thank you. Thank you. Okay, so we're looking so far so good here. Okay. Now the problem is I have to get OD in there somehow, and this is the magical step. I don't always use that. Go ahead. What? Were you going to say? I was just saying something. Yeah, that's fine. Okay, so here's the thing. I'm going to rewrite AC. What's the other way I can write AC? Oh wow, yes. Goodness gracious me. No, yes, okay. But the problem is if you do AO, that's going to get rid of this OA, so I don't want to touch that, okay? What's just another way I can write AC from here to here? 2/3 AD sounds good to me. I was going to do it a different way, but since you guys like fractions, that's fine. The answer is fractions, isn't it? Okay. I was going to say I was going to call it AB plus BC, and then call that into 2CD. That's right, the way I was going to go there. Okay, right, so that you can move like that. That would still work the same way. Okay, great. I have AD now. Can I get someone who's brave to tell me finally how I can change AD in terms of maybe OA and OD? That'd be lovely, so we can do that for me. What does AD equal? AO plus OD, sounds good. Equals OA plus 2/3 AO plus OD. Okay, why am I happy at this point? One, I'm always happy. But looking at that equation, why am I finally starting to feel good? Yeah, things start to cancel out. I only have AOs, OAs, AOs, and ODs. And my question has to have only OAs plus ODs, so it looks like I can get that to work. Okay, can I get a brave soul to tell me how that distributes, please? So this is, if you don't like this way, you can do it a different way yourself. Oops. Oh boy. Plus 2/3 AO. Plus 2/3 OD. So we're looking good here right now. Look what we wanted the question to equal, 2/3 OD. So we're looking in good shape. How can I deal with that 2/3 AO? I don't like it. Negative 2/3 OA. Perfect. So it's going to be OA minus 2/3 OA plus 2/3 OD. And to finish up, that equals then OC equals 1/3 OA plus 2/3 OD. And that is cool. You'll definitely see something like this, but 100 times more awesome on your testing results. Now, if you did it a different way, that's fine, okay? You could have also, in my solution, just on the board, I'm messy. I start with the right-hand side. Yeah. How awful is that? Right, so if you write, the thing is, excuse me, if you're writing from the right-hand side, what you would do is you'd write it as, okay, OC plus this, plus this, plus this. Sorry, OA, try again, OA equals this, plus this, plus this. Okay, 1/3 of that. OD equals this plus this. 2/3 of that, and then combining and cross everything else, and that'll work as well. All right, I'm going to example 3, which I think might be our last example. I'm going to try for one more, okay? Example 3. It's going to say prove XA plus XB. Oh, didn't know enough. Shoot, sorry. Equals XY plus XZ. Now this is a nice one because I'm giving you the diagram. Okay, so historically in the years that I've taught this course, people have liked this proof more than the others because I gave you the diagram. Now, you may say, Mr. Sadler, this looks a lot like the last example, and it does. So if you take a look, I could have written this as Z, A, B, and Y are all collinear, and ZA equals AB equals BY, and X is a non-collinear point. Okay, prove that XA plus XB equals XY plus XZ. Okay, are you ready for the challenge? Those are all collinear, Z, A, B, and Y, and they're all the same length. You can do it. Have great self-confidence. You can do it. Here we go. Well, that sounds good. Okay, now this is where this is like I wanted to do this one on the board, ladies and gents, because this is a fundamental type of question. Okay, I'm going to look at XA, and what am I going to want to change XA into? Something with XA in it. Okay, so I'm going to change XA. So what I'll do is XA I'm going to call XZ plus ZA. Okay. XB, well, we're going to need an XY. I'm going to call that XY plus YB. Okay, does that make sense where I got those things from? Because this is the fundamental important part. So the way I'm going to rewrite this now, I'm going to write it as XY plus XZ plus ZA plus YB. Okay, ZA is this way, YB is that way. All you need to do is show somehow they're the same. Well, clearly, ZA is equal to BY. So ZA is equal to negative YB. Okay, so you get the logic there, or vice versa. So then I'm going to just up here say then this turns into XY plus XZ plus negative YB plus YB. It changes to XY plus Y to XZ plus 0 vector, which is XY. I'm going to be kind to this course. You don't actually show the 0 vector there if you just want to go right through that to your final answer. Okay, how are we starting to feel? It's just so this is your substitution. That's all this is here, right? This is like just substitution. All right, I'm going to stop right here. I think I'm going to stop today. I can't believe I'm going to do this. Well, we had half a lesson yesterday, half a lesson today, so we got half a lesson. Okay, I'm going to stop that.